Okay, so we are working with imaginary numbers, and we're going to simplify the square root of negative 32. So that would be the square root of negative 1 times the square root of 32. So the square root of negative 1 is I, right? And then the square root of 32, remember if you do 32 and you keep dividing it by the prime factors, right? Get 2, 4, 2, 2, right? So 2 times 2 comes out, and then you have a 2 left over. So that would be 4i. 2 times 2 is 4, and then I have the square root of 2. Right? So we'll just write it like that, 4i radical 2. And then for 8, I've got the square root of negative 1 times the square root of 700. So again, that would be my I. Right? This I comes out because it's a perfect square. And then I'll do the 700. Right? Anything even, you just divide by 2. 350, keep dividing by 2. And so I'll get 175. It ends in 5, divide by 5. So I'll get 35. Ends in 5, keep dividing by 5. So that's the prime factorization. So a 2 comes out and a 5 comes out. So that would be 10. And then you've got a radical 7 that stays inside. And then for the 49, again, I got square root of negative 1 times the square root of 49. So that is a perfect square, so I've got 7i. Right? And then now I've got, this is the square root of negative 2, so that is the square root of negative 1 times the square root of 2. And then I've got times the square root of negative 1 times the square root of 9. All right, so this gives me I, right, times the square root of 2 times I times 3. So altogether that would be 3 radical 2. And then I've got I times I is I squared, right? And I squared is negative 1, so I get a negative. And then now I've got the square root of negative 1 times the square root of 4 times the square root of 25. So that would be I times 2 times 5. So that's going to be 10i. And then here I've got square root of negative 1 times the square root of 16 times the square root of negative 1 times the square root of 16. So that's I times 4 times I times 4. So that would be 4 times 4 is 16, and I times I is negative 1. So I get negative 16. All right? And again, that makes sense, because anytime you square something, right, you end up with what is underneath. Right? Because this is the square root of 16 squared, right? These are inverses, like undo each other. All right. So that is simplifying radicals. That's simplifying, right? This is equal to that. We're just rewriting it. Now, if we're going to evaluate, then this is equal to something else. So I to the 25th, you can divide it in 4. Remember, it's I1, and then minus, minus, right? I1, minus in the middle. Okay? So, and this would be to the first power. Let me write that better. So this is, right, that's to the first power, right, that's I to the first power. This is I squared, this is I to the third, and this is I to the fourth, right, and then it repeats. So, because I to the fifth is I to the fourth times I to the first, and so you're back at the top 1 times that. So, 25 divided by 4 has a remainder of 1, all right, or 0.25. And so that, remember we said this, oops, I don't want to do that. So this first one, right, is 0.25, so that would be 5. Okay, and then remember you can put that in your calculator with the I part. So if I take 74 divided by 4, you're looking at the remainder, and we'll just do it on the calculator. Let's see, let me get my calculator. So I'm going to get in my mode and go to my I, right, imaginary mode there, and then I can do math, arrow over to num, and I'll do I part, go down to I part, and hit enter, and then I can put in I to the 74th. The I is second, this little dot, you can see it, it's blue above the period. All right, and then that's, I'll do my up arrow to the 74th power. Right, I'm going to enter, and so that is -1, all right, according to that. And then also notice 74 divided by 4, if you're ever just have a regular calculator, so it's 0.5, all right? So notice where that is. So this was, what did we say, it was 1, or a -1, all right, because this is 0.25, and then this is 0.5. Right? This is 1/4, right? 1/4. This is 2/4, 3/4, 4/4. All right. So this would be a -1 if you have a leftover of 2 or 0.5. Okay. So then I've got I to the 64th. So I'm just going to put that on my calculator. All right, so I'll go up here, just do the up arrow, so you don't have to keep typing it over and over. Hit enter, and I'll make that I to the 64th. Hit enter, and so that is a +1. Okay, that's a +1, and then notice that if I take 64 divided by 4, all right, that's a whole number. All right, so that's 4/4. Okay, you have no remainder, so that is why it is +1. And then I to the 55, right, you're going to do the same thing. All right, so go to, we'll do it from the start just to remember. Math, num, number 3 is I part. And then you put in I, so that would be second dot, up arrow to the 55, and then hit enter. All right, so that's -I. And again, you can take 55 divided by 4, all right, and you get the 0.75, so that's 3/4, so that would be -I. Okay. Now, if we're going to do this, we're going to distribute this guy, right, just like we would any other number. So that would be 2I to the 5th, right? You add your exponents if you're multiplying, minus 5I to the 4th, and then plus 3I to the 18th. Okay, and then now I to the 5th is what? I to the 5th would be 1, 2, 3, 4. So that would be I minus 5 times, and then I to the 4th is just 1 plus 3 times, and then I to the 18th. Let's see, if we divide by 4, we have a remainder of 2, so that would be 2/2, so that would be -1. Okay. So I get 2I minus 5 minus 3. So that equals -8 plus 2. Notice that's how we always write a complex number. You have the real part first, and then you have the imaginary part. Okay? All right, so there we go. And you could just type that on your calculator as well to check it out. Just type the original thing, and you'll end up with this. So now if I'm distributing this, I'll get 5 times 6 is 30, and then that will be I. And then 5 times 3 is negative 3, right? So negative 3, so that would be negative 15. I times I is I squared. Alright, so I have 30I minus 15 times, and then I squared, remember, is negative 1. Alright, so negative 15 times negative 1, that would be positive 15. So you get 30I. But remember, complex numbers, you write the real part and then the imaginary part. Okay, so we'll come down to number 19. And now you're going to FOIL these. All right, so I've got the first 3 times 2 would be 6. And then the outer ones, 3 times 5 is 15I. And then I've got my inner ones, so that would be negative 2I. And then the last ones would be negative 5, and then that would be I squared. So now I have 6. I can combine my like terms. So this is, these are like terms, just like x's. So 15 minus 2 is 13, so I have 13I. And then now I've got negative 5, and then I squared is negative 1, right? So negative 5 times negative 1 is a positive 5. Right, so I have 6 plus 13I. Okay, and then now I have these terms I can combine. Right, now the 6 and the plus 5 I can combine. So that would be 11 plus 13I. Okay, and you can check it on your calculator by just typing that into the calculator. 3 minus I times 2 plus 5I. So parentheses, 3 minus I times 2 plus 5. So 11 plus 13I. So you can always check yourself. All right, and then this number 20 is FOILing as well. All right, so we're going to do the first 2, so that would be negative 2. The last 2, so that would be negative 6I. And then the inside ones, so that would be plus 5I. And then the last ones would be plus 15I squared. Okay, so now we have these in the middle that we can combine. And then this one is going to end up, so I have negative 2. Minus 6 plus 5 is minus I, plus 15 times negative 1. Right, I squared is negative 1. So that would actually be negative 15, and then the next one minus 2, minus I, minus 15. And then I can combine the negative 2 and the minus 15, so that equals negative 17, and then I have a minus I. And again, just type that on the calculator and check yourself. All right, and then now this is just adding, okay? So I'm just combining all of my like terms, no distributing, no anything, just combining like terms. So, and I'm going to do the real numbers first. So negative 4 plus 3 is negative 1. And then I've got 10I minus 7I, okay, 3I. So this is my complex number because it has a real part and it has an imaginary part. Okay. Number 22, this is minus in the middle. So you have to distribute the negative. It makes everything here opposite because it's negative and then these are added together. So that would be the distributive property. So I'm going to do negative 4 stays the same, plus I stays the same. But now it's going to be the opposite of negative 3I would be positive 3I. And the opposite of positive 4 would be negative 4. I just want to be able to see the columns so I can make sure I got it right. So the opposite of negative is positive, the opposite of positive is negative. So now I can combine my like terms, right? I've got, I'll do my real numbers first. Negative 4 minus 4 is negative 8. Okay? And then I've got a plus 1I plus 3I, so plus 4I. So that is my complex number because it has a real part, right? And it has this imaginary part. Okay. Real plus imaginary, and that's complex. All right. That's that. Now we're talking about how to solve these quadratics. If you do not have a middle term, if you have an x squared, right, but there's no x to the first power, then what you want to do is get the x squared on one side and the numbers on the other. So I'm going to subtract 100 from both sides. And we'll get x squared equals negative 100. And then you always write algebra, it's just the inverse, right? Taking the inverse of everything. The inverse of x squared is the square root, right? These are inverses. So that would be x. And then we said before, this is the square root of negative 1 times the square root of 100. And so that is equal to 10i. Now, if you have a quadratic, there's always two answers. All right, there are two solutions. You could have positive 10i, right? If I take 10i times 10i, that's going to be 100i squared. And so that would be 100 times negative 1, right? Which would be negative 100. But look what happens. If I take negative 10i times negative 10i, that's going to be negative 100 I squared. Or excuse me, no, it's not going to be negative. It's going to be positive. Because a negative times a negative is a positive 100. Right? If I have negative 10 times negative 10, that's a positive 100. And then, but I still have I times I to get the I squared, and I end up with negative 100. So I'm going to have plus or minus 10i. All right, and that's if you are solving a quadratic. Right? If you're solving a quadratic, you're going to have two solutions. Okay? And this would be two imaginary. That means I have on my graph a graph like this that does not cross my x-axis, right? And it doesn't cross it. There's no x-intercepts, right? And so that means there's no real solution. But what you have are two imaginary solutions. All right. So let's look at the next one. Same thing. I've got an x squared, right? But there's no x to the first power. Okay? Got an x here and it's squared. There's no x to the first power. So what I'm going to do is I'm going to subtract 4 on both sides. So I get x plus 2, that whole quantity squared, equals negative 4. Right? And then now I'm going to square root both sides. So this undoes that, and so I get everything underneath. X plus 2 equals, remember, this is the square root of -1 times the square root of 4. And so that would be 2i. You've got x plus 2. All right, now remember though, since this is a solving, right, since we're solving a quadratic equation, all right, that means it's plus or minus 2y. There's two solutions. And so now to get the x by itself, I'm going to subtract 2 here, 2 here. And so I get x equals, I'll put the real part first, -2 plus or minus 2i. Okay? And so if we look at the graph of the equation, you'll see why that is. Okay, what this is saying is you've got your x-axis, right? Your x-axis right here, and it has imaginary solutions, so it doesn't cross the x-axis. But the x equals -2 here, that is your axis of symmetry. So your parabola is going up like this, right? And it goes through x minus equals -2 is the axis of symmetry, and then you're going to have an imaginary root to the right and an imaginary root to the left. That's why you have the plus or minus. You have one root to the right and one solution, a root to the right and one solution to the left. But they're not real solutions, okay? They are imaginary solutions. All right, excellent. So, and if we put that in our calculator, you can see that that is the case here. All right. So let's go ahead and do this one. Number 25. You already have, the x squared by itself. All right. So I'm going to square root both sides, and so I get x minus 1, right? Because that cancels out with that, equals the square root of -1 times the square root of 2, right? And so x minus 1 equals, and that would be I, and I've got radical 2, right? And it's plus or minus, because I'm solving, right? We're solving, so we have two solutions, plus or minus. Let me make it so I can see that, plus or minus, all right? If I'm solving something, a quadratic. And then, so now I want the x by itself, so I'm going to add 1 to both sides. And so I get x equals, put the real part first, a positive 1. So that's my axis of symmetry right there. Right? And then on either side, I'm going to have my plus or minus I radical 2. Okay? So again, it would... and we'll go ahead and put that in the calculator so you can see it. Okay, so put this in the calculator, and I added 2 to this side because you want to have y equals something, right? So I would add 2 to that side, and then if you go ahead and graph it, there it is. Actually, let's do zoom 6 so we can see it better. All right, so see, the axis of symmetry is x equals 1, right there, right, that's x equals 1, and then either the two imaginary roots got one on the right and one on the left. Okay, fantastic, good job.